Okay, tonight we're going to take a look at the multiplication property of exponents. And again, we talked about how exponents are short ways to write really, really long numbers that are repeated over and over again. So we're going to find, hopefully, a short way to multiply numbers that have the same base and different exponents. So for example, what that means is if I have 4 to the third times 4 to the fourth, how can I do that? There's a long way and there's a short way. And we know that 4 to the third is 4 times 4 times 4, and 4 to the fourth is 4 times 4 times 4 times 4. And we need to write this as 4, and we need to have one exponent. So we want to it's basically kind of like combining like terms. So let's go ahead and get started. Okay, so we're going to rewrite each expression in expanded form. And if you remember from our video notes, our first set of video notes, expanded form just means to write it out as a list of factors. So 11 to the fourth is 11 times 11 times 11 times 11. The base tells me what number I'm multiplying, and the exponent tells me how many times I multiply that number by itself. 11 to the fifth, again, the base is 11, and I need it 5 times. So 1, 2, 3, 4, 5. So if I multiply 11 to the fourth times 11 to the fifth, 11 to the fourth, we said was 4 11s. 11 to the fifth is 5 11s. So if we want to write this as one base and one exponent, it's 11 to the 1, 2, 3, 4, 5, 6, 7, 8, 9th power, because we have 9 11s. So it's 11 to the 9th. So 11 to the fourth times 11 to the fifth is the same as 11 to the 9th power. So let's take a look at another example where the base is a variable and see if it is done the same way. So x squared means my base is x, and I need 2 of them. X to the third, my base is x, and I need 3 of them. So x squared, again, is x times x. X to the third is x times x times x. So with one base, our base is x. How many x's do we have? 1, 2, 3, 4, 5. So x to the second times x to the third is x to the fifth. So we need to try to find a shortcut for this so we don't have to write out all those x's. So let's take a look at our original expression right here. When we had 11 to the fourth times 11 to the fifth, we ended up with 11 to the 9th. And then when we had 11 squared times 11 cubed, we ended up with 11 to the 5th power. So what can the shortcut be? So if we look at our two exponents on 11, we have a 4 and a 5. How can we get from 4 and 5 to 9? Well, the shortcut is we can just add 4 and 5. So if we add them, we get 11. We add the exponents because the base is the same, 4 plus 5, and we get 11 to the 9th. Now, do you have to do it this way? You do not. You can write it out in expanded form every single time, but this is just a shortcut. So let's take a look at x squared times x to the third. We have a 2 and a 3. How can we get from 2 and 3 to 5? We can add them. So if my base is the same, and it is, and it's x, all I have to do is add the exponents, and we get x to the 5th. Will that work every time? Yeah, it will work every time. So let's take a look at the property, or the general rule for multiplication property of exponents. So the multiplication property of exponents right here. For every non-zero number, that means that x can't be 0, all we do is make sure that our base is the same. we have an x and an x. So we keep the base and we add the exponents as long as the base is the same number or the same letter. So what does this mean? So this means that for every non-zero number, this means that we keep the base. So the base has to be the same, and add the exponents. Okay, one thing I do want to mention, if there is no exponent, if we don't see an exponent, like just plain old x, then we are going to make it a 1. So then we are just going to add x is the same as x to the first power, or x to the 1. So let's take a look at x squared plus x to the third. So the base is the same, it's both x, so we're going to keep the base and we're going to add the exponents. So it's 2 plus 3, and that will give us x to the fifth. So x squared times x to the third is the same as x to the fifth. This next example is one where the first a does not have an exponent. So if there's no exponent, then we are going to give it a 1. Because what that means is a times a times a times a times a times a, which is a to the 6th power. And the shortcut, keep the base, add the exponents, and we still get a to the 6th power. Okay, example number 3. Let's look at all our exponents. The first one has an exponent of 2, exponent of 3. There's no exponent here, so we are going to give it a 1. Ask yourself, are the bases all the same? Yes, this has a base of n, this has a base of n, and this has a base of n. So we are going to keep the base, and we are going to add the exponents. So it's n to the 2 plus 3 plus 1, which is going to give us n to the 6th power. And if you're not sure, if you don't like this method, what you can do is just write them all out. So this would be n times n, this would be n times n times n, and that last n would just give us n. And do we end up with 6 n's? We do. We end up with n to the 6th power. In the next example, down here on the bottom left, we have 2 different bases. So what I'm going to do first is I'm going to rearrange the problem. I have 2 bases of b, so I'm going to write b times b to the 5th, and I have 1 base with an a, so I'm going to write that over here. This first b doesn't have an exponent, so I'm going to give it a 1. I can combine these two, so it's b to the 1 plus 5, which is b to the 6th. There's no other a's, so it's just times a and times a, and that's our final answer. We cannot combine the a and the b because they are not the same base. Our next example kind of changes things up again, and again we're going to rearrange them. So this example, there's coefficients, there's integers, there's numbers around here. So this means 6 times y squared times 3 times y cubed times 2y to the negative 4. So we're going to rearrange them again. So I'm going to take all of my numbers, my 6, 3, and 2, I'm going to write them first. Then I'm going to take my like bases, they're all y's. So times y squared times y to the third times y to the negative 4. I'm going to multiply 6 times 3 times 2, and that's 36. And in this section, I have the same base, so I'm going to keep my base, and I'm going to add my exponents. So I have 2 plus 3 plus negative 4. The 36 is not going to change. And 2 plus 3 is 5. 5 plus negative 4 is 1. You can write it like this, or you can write it as 36y, because y to the first and y to the 1 are the same thing. Okay, last example on the front. We have different coefficients, 5, 2, and 3, and we have different bases. So I'm going to regroup my numbers and my letters. So I'm going to regroup my 5, my 2, and my 3. So it's 5 times 2 times 3. I have a base of m here. Doesn't have an exponent, so I'm going to give it a 1. And I have a base of m here, which has an exponent of 8. And then I have p to the 4th. 5 times 2 is 10. 10 times 3 is 30. I can combine my bases here. My base is m, and that's 1 plus 8. And p, there aren't any other bases of p, so I'm just going to rewrite it. So my final answer is 30. 1 plus 8 is 9. And p to the 4th stays the same. And again, I can't combine these two because they are different letters. Okay, flip your paper over and take a look on the back. There are 12 examples. I would like you to try 10 of them, and if you have me muted, then I guess you can't hear that. So the directions say to simplify, your answer should contain only positive exponents. And I believe your answers will only contain positive exponents. So, for example, in number 1, do we have the same base? We do. It's 4 squared times 4 squared. So again, keep in mind, we can write 4 squared times 4 squared as 4 times 4 times 4 times 4. Or we can use the shortcut, keep the base, and add the exponents. And either way, we get 4 to the 4th power. Don't multiply out 4 times 4 times 4 times 4. Just leave your answer as a base and an exponent. So one more that I would like to do with you is number 5. So number 5, we have some integers in there. We have a 2 and a 5, so I'm going to rewrite those. I'm just grouping like things together, and the 2 and the 5 are just numbers. They don't have any exponents, so 2 and 5 are just the base. And then we have n to the 4th and n to the 4th. So I'm going to rewrite those times n to the 4th times n to the 4th. 2 times 5 is 10 times n. We add the exponents to the 4 plus 4, and our answer is 10. And 4 plus 4 is 8, and that is our final answer. So we'll check the rest of these in class tomorrow, and again, if you have any questions, please write them down on your notes so you can ask them in class. Have a good night.